Hello,
Hello.
what's up?
Not much.
How's everybody doing?
All right.
Nice. All right, all right. I just got that email from Venkat about a paper attached. Can't see it. Got to log on to 5 different accounts to find it. Classic Outlook. How's your building design coming, Alicia?
I what?
Your building design, the trace?
Oh, I haven't worked on it since.
I completed the entire second floor, and then I had the very, very last part I was trying to put in. It wouldn't let me edit it, so I had to delete the whole entire thing.
Yeah, I can't figure out how to rotate my building. It's like 100 degrees off.
Hello, Dr. Mary Thamathu. How are you doing?
Hey, good. How are you, Tim?
Good. Excited to hear about this new news you got.
All right. Well, okay. Shall I start, or are we waiting for somebody?
We're waiting for one more. If you could wait for like 1 more minute and see how
Yeah,
that
sure.
goes.
Yeah, that's fine. I can wait.
Awesome. How have you been doing?
Oh, doing all right. I didn't have a chance to go to the lab, but I did have the chance to take a closer look at the data for your project, and then I realized something that we can do even without the software cooperating.
Okay.
Right. So I guess I can wait. I'll wait a bit till everybody's here.
Thank you, Kylie. I appreciate it.
I got you.
Can I share my screen?
Yes, sir. I believe she
made
gave
you
you co-host. Yeah.
Okay.
Yeah, I made you a co-host, so it should work.
All right, cool. Okay, so I just emailed a paper to you guys, and the only thing in the paper that's relevant for you guys is equation number 2, which I will write down. I mean, I'll sort of indicate what it is, but when you do the computation, you will need that. So, okay, shall I start?
Yeah, you can go ahead and start.
So who's
Start
missing?
Brandon is missing.
Oh, okay. I can wait, or I can go ahead, whatever.
Well, it's just undetermined on how long it might take him to get in, to be honest.
Okay.
Sometimes he'll be in a minute. Sometimes he might show up 20 minutes later.
Okay, so how about I start, and then you guys can fill him in if need be.
Yes, sir. It's recorded, so if anything, he'll be able to look back.
All right.
Yeah, you'll be fine.
So the raw data for that came out of the experiment was basically a mag bead image, face image, with force, and then a reference, or I should say no force mag bead image, and then a corresponding, by the way, W is width. Okay. And there was also a fluorescent bead image with force, and a fluorescent bead image with no force, right? So the fluorescent bead, so initially without any force, you see the magnetic bead, and then right underneath it, you see a bunch of fluorescent beads. So ideally, this fluorescent beads should be so dense, densely packed that it's.
Hello? Hello? Can anybody hear me?
I can hear you.
Okay, I didn't know if it was me.
Maybe his mic broke.
I may be frozen. Can you guys see me now?
Yeah, we can now. Yes, sir.
Okay, I think the problem is just basically at my end. So once in a while, my internet freezes over. So for 5 minutes, you can't hear me. But if that
Okay.
happens, let me know. Yeah.
Okay, yes, sir.
Otherwise, I'll be speaking into the void. But all right. So the fluorescent beads usually, I mean, ideally should be spread all over. There should be a bunch of them all over the place. But we have some in some places, but then in other places you have none, and so on. Okay. Also, ideally, we want fluorescent beads beneath the magnetic bead all over, but we don't have it all over. We have it only in some locations. We have a bunch of them here, and then a bunch here, and so it's not uniform. Okay, so that's a limitation of our setup, at least for that day. Now, with force, basically what you see is again just a magnetic bead, but presumably what's happening is there is some kind of force being exerted, right? And again, you have a similar fluorescent bead image. Typically, what will happen is if the force is high enough, you will see the fluorescent beads maybe somewhere in this region get displaced. But what happened in your case, in your setup, was that there was one fluorescent bead over here, this bead alone, that showed a displacement, right? For whatever reason, I thought that was right underneath the magnetic bead. But if I actually superimpose, okay, before I say that, this image and this image, they are aligned with each other because I take one image right after the other, okay? In the same fashion, this image and this image are already aligned with each other because I take the image right after each other. But these two guys, and therefore these two guys, are not pre-aligned, okay? So there is some drift, which I think mentioned previously, because of some external noise. The camera takes an image, and then when it goes back to the same position, it's not really the same position, it's slightly shifted, maybe by 5 pixels X direction and 10 pixels Y direction or whatever. But the bottom line is it's slightly shifted. And so we have to align all the images together, especially basically these two images we need to align. So I think Brandon mentioned that he did align those two images, right? Actually,
Yes,
he did do it because that's how we were able to see that this micro bead was actually moving.
Yeah,
right?
the stack, yes, sir.
Right. If you don't align it, you can't see it moving because everything will look like it's moving because of the drift, right? So he did align it, and that's how we could see that motion. Anyway, but these two are pre-aligned. So even before you align stuff, you can actually compare the magnetic bead and the fluorescent bead image to check and see let's say this is the fluorescent bead that's moving. Where is it relative to the magnetic bead? And if I do that, if the magnetic bead is over here, the fluorescent bead that's moving is around over here, roughly speaking. Okay, this is a fluorescent bead that moves, and this is the magnetic bead. Okay, oops. By the way, I mean, even though I've drawn it like this, the fluorescent bead is actually underneath the magnetic bead. So the side view would be like, this is the magnetic bead, and this is the fluorescent bead over here. Okay, the top view or side view, sorry. Okay, now now that that is out of the way, the situation we have is something like this. The force is being exerted here. So let me take the midpoint of the magnetic bead and say that the force is really acting over there. So that's the force. And if I look at the side view, I guess I can't show it as effectively because the direction is different. So I can maybe draw it like this. The force is acting at the point where the force is acting on the magnetic bead, but the force is getting transmitted to the surface at this point where it touches the surface, right? And the displacement of the fluorescent microbead is like this. Okay, I'll call it U. And similarly, I'll say the displacement of the fluorescent microbead is U. Okay, and again, this is the surface on which everything is sitting. Okay, actually, we should draw it like this. Right. So again, let me go back to the top view. And in the top view, basically, if you have a large surface, And if you have a single force, let me just draw it like this, F, and let's say this is F x component and F y component. So if you have a single force exerted at a point, then this will cause a displacement all over the surface, right? Just like on a carpet, if you stick your foot to the carpet and then drag your foot, the carpet will move not just underneath your foot, but even like a meter away, you'll see the carpet moving. So in the same way, at any random location, let's say you take a distance r, and if you pick a point there, there will be a particular displacement. I'll draw the displacement like this. Well, let me actually draw it in this way. Let me draw it like this, u. And then again, this is the x component of the displacement. This is the y component of the displacement. So again, u is displacement, F is the force. Okay, like we said before, if it's just a linear spring, you will say F is equal to K times U, and then you're done. But because this is an elastic medium, it's not just one spring constant that relates it, but it's a more involved equation. So if you look at the paper, you can look at it later, that I sent you, there is an equation 2 in it that basically has an expression for a quantity called uppercase G. Okay, it's called Green's function. It's not relevant, but the bottom line is it relates basically uy and let me just say ux uy, ux component and uy component are related to fx component and fy component. Oops. Using these terms gxx, gyy, gxy, gyx. Does this make sense so far?
Yes, sir.
Okay. And so just like we have this equation, like that for this elastic medium, we have this equation, right? So you can basically say ux is equal to gxx fx plus g xy fy, and then another equation for ui. Okay, so you can write another equation for ui from this matrix multiplication on the right. So bottom line is you can relate ux, or you can relate u and f, right? So this is the situation we have. So what I thought is when we have many when you have many fluorescent beads underneath the magnetic bead, once you apply a force on the magnetic bead, you will see a bunch of fluorescent beads underneath move. So this will move here, this will move here, this will move here, and so on. So I thought we will see a bunch of them move. But because we did not have fluorescent micro beads right underneath the magnetic bead, I think the closest one we had was this guy here. We could only see this guy move, only this fluorescent micro bead moved. So our question is, when you have U for, say, this is the location of our fluorescent microbead. So you have the displacement, okay? And if you compare these two images, this image and this image, after aligning, then you see that this this fluorescent microbead moves about half a pixel, right? So U is around half a pixel. And I don't know if I gave this information before, but I imaged this stuff using a 20x objective. So for a 20x objective, the conversion factor is let me write it like this, 6.45 divided by 20 microns per pixel.
Is that the 0.3 number?
Which one I asking about?
Pixel to micrometers, the 0.322.
So this, yeah, that's right. So did I give that earlier?
Yes, sir. I
Okay.
emailed you a little while ago. about it.
Okay. So I forgot what I mentioned.
Oh no, it's fine.
Okay.
This is good
So it's
information.
the same thing. Okay. So basically the displacement is around half a pixel, you can do some analysis to show that it is half a pixel. But by just me staring at it, it looks like it's half a pixel, right? You can check that yourself. So you can convert half a pixel into micrometers using this conversion factor. Okay, so that's one thing. So basically, at the end of the day, you have the displacement in micrometers. So that's one thing. The second thing is, if you actually compare these two images and see what the displacement is mostly along x direction. So U is mostly along x, right? So you can actually compare the images and get a more accurate measure of y along with ux and uy. But I would just say, because we are doing a rough estimate anyways, you can just take it as just along x, right? U is basically along x. And so if you use these equations here, so you'll have a ux, which is what you will measure from the two images. Uy is basically 0, okay? Because we are being rough, we can just say uy is 0. And so what this equation will give you is basically, if you look at this, ux is going to be gxx times fx, okay? These equations will tell you that fy is basically 0, okay? Because uy is basically 0, and so on, okay? But at the end of the day, you will have u basically along x direction, and then you will have the force also basically along x direction, luckily in this case. So you have a force that's basically along x. And F and U are related using this gxx. Okay. So I think if you look at the paper I sent you, gxx turns out to be 1 plus mu pi e r cubed. This is something directly from the paper, okay? Times 1 minus mu r squared plus mu x squared. This is what you have, right? So in this gxx, by the way, this nu is the Poisson ratio, and you can take it as basically 0.5, okay? Because this is basically incompressible, and so you can take this as 0.5.
Yeah, I think that's what he was using on the website as well. I think
okay,
that's like stock standard.
Cool. And if you look at this image, the fluorescent microbead is basically directly below, right? So it's slightly deviated at an angle, but you can take this r as basically the y component, okay? So r is square root of x squared plus y squared. We're talking about the distance between the center of the magnetic bead and the fluorescent microbead.
Okay, and E is Young's modulus, right?
Correct.
Okay,
E is the Young's modulus, and I told you what the value is, right?
Yeah, yes, sir.
So you have that. And because the fluorescent microbead is directly below the center almost, R can be approximated as just Y instead of this, okay? And so you can plug in R equal to Y instead of X. Let me see if that's what I did. It's going to be, I think, let me see. R is basically Y. Okay, that makes sense, right? So, and so you can plug, instead of R, you can just plug in Y here and here, okay? And then what else do you need? I guess that's all. So you will have gxx, you will have ux. So from that you can get fx, which is basically f, right? So from this you can calculate what f is going to be, because it's just a simple relationship between ux and fx. Okay. Does this make sense so far, or do you guys have any questions?
Yeah, it's just a little bit putting together for me right now.
Yeah. Okay. So I guess later on, if you think of any questions, you can let me know.
Yeah.
Right?
Anybody have any questions?
Yeah,
So-
so
yeah.
when you find UX and then you need to find FX, that's
Uh-huh.
just related by R, the distance.
So UX is equal to GXX times FX, right?
Mm-hmm.
And GXX is this. And so GXX basically depends on the Poisson ratio, the Young's modulus, and then the R and the X basically refer to the coordinate of this point with respect to this point. Okay, so R is the radial coordinate of, let me call this let me call this A, and let me call this B. So R is the distance between A and B. And so that feeds into GX here and here. And X is the X difference between A and B, which is almost zero because B is almost directly below A.
So y will basically be 0 for that magnitude. So y x squared plus y squared.
I'm sorry, what will be zero, you said?
When you were saying r is basically equal to y, you change y in the equation from r.
Yeah, so instead of R, you can basically plug in Y. Basically, this distance is going to be Y. Right? Because,
Yeah,
so
because X is 0. So.
does it make sense?
Yes, sir.
Yeah,
Yes,
okay.
sir.
So X will be 0, that's right.
Gotcha.
Do we have Y, the value for it from the image?
So that's the thing. So once you align these two images, then you can, actually you don't need to align. So you can actually just look at these two images,
Okay.
right? So in these two images, you need to locate the center of the magnetic bead, right? So, I mean, there are some ways to fit a circle to the magnetic bead and find the center and all that stuff. You can do that. Or you can just manually try to locate the center, right? You try to locate the center many different times and then take the average. And then you'll find that it's not going to be that different each time.
Is the magnetic bead lined up with the fluorescent bead?
Yeah, so that's the first thing I said, right? So these two images are already aligned, pre-aligned.
Okay, so
and these two are already pre-aligned.
Gotcha. So we could just literally take the point that corresponds to the picture as the
Correct.
middle.
So you can just
Correct.
compare these two images right away and
Gotcha.
locate the center of the magnetic bead and locate the position of the fluorescent bead.
Okay. But since both pictures are lined up, we could just take a point from that picture, a reference point, and then it'll be the same exact on the other picture as well.
Correct.
And it'll be the middle of the picture. Gotcha. Okay. And then what'd you say after that? I'm sorry.
And yeah, so the center of the magnetic bead you have to locate. And in image J, it's very easy, right? In image J, it will basically tell you the coordinates, X and Y.
Mm-hmm. Yep.
So basically you find the position of the magnetic bead center, and then you find the position of the fluorescent bead, and position of the magnetic bead center is this A here. That's where the force is acting. Position of the fluorescent bead is this B here. That is what is getting displaced. At least that's where you're recording the displacement. Okay, and the relationship, so like I said, when you have a force at a point in a continuous medium, it'll cause displacement all over the media. But it turns out that we are able to measure the displacement only at this point B, right? And points farther away will get displaced, but we can't detect it because it will be so tiny. Points closer to B, closer to A than B should displace, but we didn't have fluorescent microbeads right underneath the magnetic bead. So we couldn't see the displacement, right? But is it clear how you use this equation to find Fx so far, right? At least right now it seems to make sense, correct?
Yes, sir.
Okay. So basically you'll estimate the force, okay? So if you estimate the force, my guess is you might, 1 minus the same times y. Well, so let's see what value of force you get, okay? You might get some force in nanonewtons, okay? But it looks like it is an appreciable value, okay? So you'll get a sizable value.
Okay. I'm guessing you've done this already, and you.
Well,
you've
I
done that.
roughly did it, but I'm not sure if I messed up in one place or not, okay? I got
Gotcha.
like 15 nanonewtons or something like that, but I may have made a small error. So the actual answer, it may still be 50, or it may be 30, or it could be 10. It doesn't matter, but it's an appreciable force.
Gotcha. Okay. Well, that's good. Really good
So
news.
the question is, why did I not see displacement of microbeads elsewhere? Okay. So maybe that's the reason why I didn't spot this earlier, because I didn't get a proper result in many locations. And so I guess that sort of biased my mind. But
Did you say that was due to the beads?
what was that?
Did you say that was due to the fluorescent beads just not being enough?
Well,
around the
so
bottom, maybe?
I guess in some locations when I tried it, underneath the magnetic bead, there was a very low density of fluorescent beads. Okay, so that is a factor. Okay, so that is a factor. The other factor is, so in the chamber that we have, if this is the chamber, the magnetic gradient is fairly uniform here. Okay, so gradient of the field induction is about constant. Okay, but the magnitude of B itself is low here in the center. Okay, so here B is low and it gets high only around the edges. Okay, the force actually depends on the gradient of B as well as B itself, the value of B itself. But B is actually fairly low within this region. But that's where we have the cover slip. So the probability of success is high over here and it's low over here, right? So I just imaged wherever I found magnetic beads, but maybe there were a bunch of them near the center. And so, and because B was low, the forces were low, but maybe I found some at the edge of the region, and there B is higher because B sort of increases radially. And at the edge, because B is higher, maybe the forces also got higher in that particular location, right? So that's one thing. The third factor is there's going to be variability with magnetic beads themselves. So, you know, these guys sell these magnetic beads and they say that, oh, it has these properties and so on, but there could be a lot of variation from bead to bead. Even though the bead looks the same in terms of diameter, the amount of magnetic material, the magnetic content may be dramatically different from bead to bead. So maybe I luckily found one that had a high fraction of magnetic content, you know. So that's another possibility. And one interesting thing is this bead was actually not 50 microns. If you actually measure the diameter of the magnetic bead, I think I found like 17.5 microns or something like that, the diameter. Was it the radius or diameter? I think it was the diameter, if I remember correctly.
I hope it's the radius.
Well, it shouldn't really matter to you, right? It's because again, 50 micron magnetic bead is what they sell, but there's going to be a distribution of diameters, and you know, when you plop them down on the surface, you find one that's smaller, one that's bigger, or whatever. But it is what it is, right? So you can actually go on image J and measure the diameter of the magnetic bead, and you can see for yourself as to what it is. Okay.
Okay.
But you want to accurately report it, so you don't want to say in your final report it's a 50 micron bead, and then you know the actual image has something different, right?
Gotcha. Yes, sir.
So yeah, so my guess is those are the factors which underlies the big variation that I saw. But again, I didn't have time to go as many times as I would like to really nail it down. Okay, ideally what I would like to do is wherever I find a magnetic bead, let's say if I find a magnetic bead here, I would like to record the radial location of this position so that I'll know whether B is expected to be low or high, and then I can correlate it with the forces that we find. But I didn't get the chance to do that, you know. But I think I said my piece. So yeah, this is all I got. So are there any questions based on what I was rambling about so far? Or is it clear?
I don't have any questions at the moment. Does
Okay,
anybody else have anything they want to ask?
cool. So just
Pretty
the
cool.
paper I sent you basically has the equation 2 has this matrix G basically. Okay, and so just look it up, and I think the GXX you will find should be this. Okay.
Okay. When we get some numbers, we'll try to get in touch with you and see if we got the same kind of
All right.
answers.
Cool.
I appreciate you coming in today, and thank you for all the help.
All right. No problem. Take care, guys.
Yes, sir. You take care too.
Yeah. Hold on. My mouse doesn't work at the extremities. Hold on a second.
You're
I'm
fine.
still here.
It's the
My
pressure.
leave, but I clicked the leave button, but my mouse won't work on the corner. So I got to minimize the screen and then hit leave it, leave. This is so annoying.
Kylie, can you kick him out?
Oh Lord. There we go. Kylie, can you?
She's the host.
Oh my God, brutal. Okay, how'd everybody take that in?
I was taking notes. I followed along, so it's good.
Nice. Yeah, doesn't look too bad, especially when the Y cancels out. It's a lot easier. But yeah. What did he say? Did he say he got 15 nanonewtons or 50 or something like that?
I wasn't listening to that part.
Yeah, I'm pretty sure he said he got from 15 to 50 nanonewtons.
Wowie.
So yeah, I mean that's dramatically higher. MSJ is super simple as far as those lining up. I can figure that out like super easy.
So can you get that Y value, the R? I guess they're the same. R equals Y.
Yeah.
Okay.
But yeah, I can pull it up on MSJ and mess around because it's super simple to do up there as far as just figuring out where the point is and like the distance of things from the pixels. That's really easy. What do we got coming up this week? Last night I was waiting on Brandon. Brandon said that he was gonna work on the status report. 11:30 came.
I thought that was Monday night.
Either night. I'm not for sure. I'm sorry. My days are kind of mixed up. I've been super busy lately. But yeah, and didn't do it, so I didn't have any time. I literally just changed like 5 words and posted it because it was due at 12 o'clock. Just throwing it out there. I didn't have anything to change the Gantt chart because it was already too late. So I just left your name on it, Alicia. But this week we need to. Can you do the weekly report this week?
Yep.
Alicia? Nice. Okay. Other than that, do we have anything going on in class?
How did yesterday go with the advisors? I mean
Went fine. Venkat said he would or not Venkat, Zhang said he wanted to talk to Venkat, and then he said he might reach out to a couple people just talking about class stuff. But other than that, nothing crazy.
Yeah, I think just upcoming, we have our final presentation and then the poster.
When is that due? I'm trying to, my freaking move stuff is almost up.
these dates down.
I put it in the Google Drive. Let me.
Yeah.
The poster for us is just like a file. Not printing anything.
I don't know if we're printing it. I think we submit it and they print it as like
Yeah.
the TA.
Yeah. I don't know too many people that got poster printers.
Yeah.
That'd be
I mean,
brutal.
like, I don't think we have to reach out and have it printed or deal with that. Like,
Oh yeah, no. Yeah, and I mean, when we told Venkat, he was like, "Yeah, poster? What? You put nothing on the wall?"
we're probably his first undergrad group.
Yeah, he is nowhere to ODU. I remember taking him for thermo, but
I'm pulling it up right now. I
we'll
don't- I'm
try to
aware.
get some stuff going for that, and I can try to get up with Brandon. I don't really know what we kind of need him for right now. But I'll be able to probably tonight. Let me see.
So
Either-
everything's due the 27th.
of April.
Yeah, but
7th of April.
I don't think we should procrastinate because our final will be due, the presentation will be due, the what, like everything being done,
Yeah, I agree.
and then we will present on exam day.
And when is that?
I forget. I
I
think I,
have May 6th written down.
yeah, I think I do too, actually, in my calendar. Let me see real quick. Actually, I do.
That's like 8 days, 8 or 9 days after.
Yeah. But unless they change it, that's what it says. They probably want to go through and grade it because we're supposed to graduate the 7th, so.
Yeah, that's true. All right, let me see what I can do tonight. I'm honestly, I don't think I'll be able to get to it tonight. I got too much on my plate right now. Tomorrow I can probably look at MSJ and figure out what's going on with that. But tonight I don't think I'll be able to. Got too much stuff going on.
I mean, if we can wrap it up in a week and then all we got to worry about is the final, the finishing touches, you know? 'Cause
Yeah,
we
yeah,
pretty
yeah.
much have to go in, tweak the midterm, add the stuff that he suggested.
Yep. And then put like I feel like the biggest thing that's going to be the change is going to be the next steps, kind of what's going on, like discussion or something like that.
Yeah, it'll just be the what we did and how we finished.
And
Right.
then what we could do to better the device or something like that.
Yeah, has he posted a final report template for them? Like, is that like a section? Or is that part of the personal reflection essay? I don't know.
I don't know either, to be honest.
I don't think it'll be I think it'll take time, but not like we're starting from nothing. Does that make sense?
Yeah. Yeah,
For
'cause-
the final report, there's only a rubric.
Oh yeah, you're right, because it's graded by our professor.
Oh well, I'm fine with that. I am completely fine with that.
VinCat grades it, yeah.
Yeah, I'm completely fine with that.
Yeah, it sucks about that figure thing, like the F not being capitalized because we did it in the midterm because that's how we got it out of like, I think the thermo textbook or whatever, because we went back and forth and they didn't hit us on the midterm or the final report in.
What now?
Did you look at the things that they hit us on for the paper?
Yeah, it was really minor stuff.
Yeah, it was minor, but they hit us on how like we didn't capitalize like figure, the word figure.
Oh.
Yeah, the final report in 434, we didn't capitalize it and it was okay.
Wait,
Wow.
did Venkat grade that report too? The last one?
No.
I don't
No,
have
he didn't. No, he didn't.
He didn't?
It's only for this semester.
And he's grading the final one?
Yeah. Yep.
Yeah.
Interesting.
Yeah.
I think the other professors grade our presentation.
Yeah. I mean, this class just kind of like this shouldn't be a worry about class.
Yeah.
You know, it should be just put some stuff down, do it right, and turn it in, kind of thing. Move on.
I'm only worried about questions that the Chinese professor, what's her name?
Oh yeah.
The materials and dynamics one. I'm just like, oh, just don't ask me a question.
The one who dropped like question 1, then my next question. Like, you got some stuff going on if somebody's dropping 2 questions and then we didn't even let you finish the first one.
Can we phone VinCat? Just kidding.
Oh my god.
Yeah, but all right, I got some stuff to take care of before class, so.
Yeah, that's cool. Everybody, just if everybody could just play around with the equations and stuff. I'll try to get some numbers and stuff for tomorrow, and we'll go from there.
All right,
Sound good? And
Yep.
this will be the weekly meeting, so no meeting tomorrow. All right.
precisely. We'll have a meeting on Tuesday after class.
Yep. Everybody good? Anybody got any questions, concerns, thoughts, anything?
Nope.
All right, I'm ending it.
All righty. I'll see y'all later.